Chapter 5, Section 2, solving by graphing, and I'll show you how to do it on your calculator. If I were to try and solve this equation right here by like subtracting a 3 or dividing by 4 or dividing by x or square rooting everything, it wouldn't work. I can't solve equations like this using our old Algebra 1 methods. I need new methods. And we'll talk about a lot of those methods in this chapter, but the first one that we'll talk about is how to solve by graphing. I can't graph this equation right here the way it's written because there's only one variable. I can't graph that. But I can graph the equation y equals x squared plus 4x plus 3. And if I graph that equation, it'll look like this. Just take my word for it, check it. That's how that graph is going to look. Well, this graph shows every possible solution to the equation y equals x squared plus 4x plus 3. So for example, if the x value is -1, the y value is 0. The point -1, 0 solves that equation. I can plug -1 in for x, I'd get out of 0. If I plug in 0.5 for x, I'd get out of 5. And that 0.5 is an estimate. I'm not totally sure that's right, but it looks like if I plug in 0.5 for x, I get out of 5 for y, because this is the point, 0.5, 5. I can check that in my calculator if I wanted to, or just plug it in and see what I get. But the idea here, the important thing, is that this graph is solving the purple equation that I wrote. And I can use that purple equation to answer questions like this. This is asking where does the y value equal 0? What x value can I plug in to get out a y value of 0? Well, those x values are -1 and -3. They're the roots. If x equals -1, or if x equals -3, then y would equal 0. And I can check that. I could do f of -1 and see what I get. -1 squared is 1, minus 4 is -3, plus 3 equals 0. F of -1 gives me 0, so I plug in -1 for x to get a 0 for y. Here's another one. When does x squared plus 4x plus 3 equal 5? I think I've actually done this one. Basically, I'm wondering where is the y value 5? It's like I plugged in a 5. I plugged in a 5 for this y value here. Well, the y value equals 5 here and here. So that's on this line where y equals 5. Well, the x values there look like they're -4.5 and they look like they're 0.5. Now, those are estimates, so I'm going to say x is about equal to -4.5. and x is about equal to 0.5, and that's when they give me a y value of 5. Okay, another one. When does it equal 3? We can see pretty clearly that it equals 3 here at the x-intercept, so when x is 0, and here at that symmetric point when x equals -4. Last one, if you want to pause and try this one on your own, that might be worthwhile. Where is there a y value of -2? Here's the line y equals -2. My graph never actually has a y value of -2. I can never plug in a -2 for x, or I can never plug in anything for x to get a -2 for y. This has no real solutions. This one cannot be solved. It's just not possible. If you remember the stuff we did in Chapter 2, I would give you some random weird graph, and we can kind of think of this as being some random weird graph. And I would say, okay, looking at this graph, what is f of 3? And you would go to 3 on the x-axis and see what it came out to on the y-axis. In this case, it's going to be a very large number. Or I can say, what's f of -2? Well, f of -2, I'd go to -2 and look at the y point, and that's -1. And we're doing the same thing here. It's the same idea. We're just trying to find specific y values. I'm going to solve this equation. 5 equals 2x squared plus 4x plus 1. So I'm going to graph it. I'm going to graph the equation y equals 2x squared plus 4x plus 1. I can find the axis of symmetry by doing -b over 2a, which is -4 over 2 times 2, which is -1. So I have an AOS right here. And I can do f of -1 to find the vertex. 2 times -1 squared is 2. minus 4 is negative 2, plus 1 is negative 1. It's this point right here. And remember how I talked about this number, this a value, can count as your first step from the vertex? This is a good thing to remember. So I can actually just go from my vertex up to right one and up to left one. And I can get a real quick point there. That also shows me that the y-intercept is 1, which I knew because from this thing here, the y-intercept is going to be 1. Okay, I'll find one more point just to try and get a decent graph out of this. I'm going to do f of 1 because that's right around. I've already graphed this point, and this point. So I'm going to plug in a 1 for x to see what I get out. So if I do f of 1, I get 2 plus 4 plus 1, which is 7. So I have the point 1, 7, which means I have the point negative 3, 7, because these are symmetric. And now I go like this. I got a fairly narrow parabola. Now I can try to answer the question. The question is, when does this equal 5? Well, the y value of 5 happens here and here. So I'm going to estimate this right now. I'm going to say it looks like it happens when x equals negative 2.9, because that's what this value looks like. And it also happens when x equals 0.9. Those are not perfectly accurate, but they at least give me an idea of where that happens. Another way you can handle this is on your graphing calculator. I'm going to type this equation right here into my grapher. So I do that, and I do y equals 2x squared plus 4x plus 1. And then I'm going to graph that and see how that looks. Well, that's a pretty good graph. I could change the window to kind of match what I've got on the screen, but I think that's really what I have. If I wanted to zoom in, I could. Now remember, what I just graphed, the calculator's going to disappear for a second. What I just graphed was this equation here that I've now circled like a trillion times. But I really want to know about what happens when y equals 5. So on my grapher, I'm going to make another equation. I'm going to make the equation y equals 5. And that's going to graph this horizontal line. And that horizontal line is just like the green horizontal line you see on my graph. That green dotted line on my graph, it's just like the one over there. Let me just show what I'm talking about. It's just like this line right here. Just like that horizontal line. I'm going to make it so this calculator always stays on top. Good. So what I'm really wondering is, where do these intersect? Where is this point of intersection? My calculator, if I do second trace as this calc menu, we've talked about finding the point of intersection before. It's asked for the first curve. Well, now I want to get this x close to the point I'm looking for. I'm going to look for this point right here. So I take that little spider and get it just to the left of that point of intersection. Hit enter. Then it jumps over to the other line. I want that very close to the point of intersection that I'm looking for. I hit enter. It says yes. I'm going to skip that, hit enter again. There's one of my solutions. There's actually x equals 0.73, not 0.9. And I can do it on the other side. I'll do it again. Second calc. Scroll down to intersect. Scroll over this way. Boom, 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 boom. All the way to the left, 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 left. I'm going to hit enter here. Then hit enter here. One more time. It shows me negative 2.7. A much more accurate way to find that point of intersection and solve this equation on your graphing calculator. The last thing we're going to do real quick. If I'm given a table, how can I find the roots? Remember that the roots are the x-axis. So I had to pause for a second. If I want to find the roots of this equation, well, the roots are the x-intercept. So really what I'm looking for is when do these y values go from positive to negative or from negative to positive? When do they switch sign? Because if I can find when they switch sign, I don't know why that's not working. I was going to say sign, but now it says switch side. So I'll probably just say that from now on. If I can find when they switch side, then I can find when we cross the x-axis. Because if you've crossed the x-axis, you've gone from negative to positive. Well, these y values are switching side here and here. This is where they go from negative to positive or positive to negative, one or the other. So I know that my x-intercept is somewhere between these two and these two. So my x-intercepts are going to be between -2 and -1, or between 0 and 1. You've got a few problems in your homework that ask you about this. Here, my y values switch sign at this point here, so it's between -5 and -4, or between 0 and 1. These words say between, just trust me, that says between, really it does. Because the y values switch signs, I know that I'm crossing the x-axis, because to go from a negative y to a positive y, I must cross the x-axis, so somewhere in this range are going to be my intercepts. Thank you for your time. Have a wonderful